Professor Radha, please, the session is yours. Please carry on.
So good afternoon and a hearty welcome to the fourth day of the 5 days international webinar on linguistics, machine learning and uncertainty theory 2021, organized by the School of Applied Science and Humanities of Haldia Institute of Technology. Haldia Institute of Technology, affiliated to Maulana Abul Kalam Azad University of Technology, is the first private engineering college in West Bengal having grade A in NAC and 13 engineering courses running in all NBA accredited departments. And this institute has always been acting as a true hub of knowledge from the very day of its inception. This international webinar, having so many erudite scholars speaking and enlightening us on so many varied topics related to the theme, attests that only. And like the former 3 days, today also we have some such speakers from different corners of the world, from renowned, world-famous universities to grace our webinar. And today we are blessed to have our program chair, Professor Radha Bhor, a very busy person indeed, and an eminent scholar and the head of the Department of Applied Science in Maulana Abul Kalam Azad University of Technology, formerly known as West Bengal University of Technology, to chair the first speakers session. Welcome, sir. And with this, we also welcome our first speaker, Dr. Radek Doskosel, Associate Professor from the renowned Brno University of Technology of Czech Republic of United Kingdom. He is the Faculty of Business Management in the Institute of Informatics, and today he is going to speak on fuzzy modeling in project management. He is an avid researcher who has already penned down many research articles in this field. To name a few of his works so that we can understand in which area he is working these days, they are the path modeling of the robot motion between obstacles in MATLAB software, brain electrical activity mapping in military pilots during simulator trainings, non-contact measurement systems for physiological data monitoring of military pilots during training on simulators, review and application, etc., etc., etc. And all these, whatever I have said, are published in the highly esteemed IEEE. So now we request Dr. Radek Doskosel, having expertise in simulation, model-based design, tetrainates, and so many, to kindly deliver his talk and illuminate us. Over to you, sir.
Okay, thank you for a very nice introduction of my person. So I will share my presentation. Can you see my presentation?
No, not coming yet.
Now is it okay? Can you see my presentation, please?
Yes, sir, it's coming. It's coming.
It's coming?
Yes, sir. Yes, sir.
It's fine?
So just wait for a while. It's not fully.
This is the first slide. Can you see it?
No, sir. I think due to some internet issue, I think it's going to come.
Please refresh your bottom, then it will come, I hope.
Now is it okay?
No, sir.
Not coming yet.
I mean,
Sir, would you mind to start it from the beginning, this presentation part? I mean, if you just do it over again. Yeah. Now, sir, if you can do it again.
now, can you see my presentation?
Yes, sir. Yes, sir. It has come. Sir,
Yes,
it's
yes.
come.
It's fine?
It's
Yes,
fine.
sir. Now it's absolutely fine, sir.
Okay, super. So, good afternoon, ladies and gentlemen. First of all, I would like to thank for the invitation to your conference. Many thanks for Professor Deepak Kumar Jana for Haldia Institute of Technology for the invitation. And my name is Radek Doskočil, and I am from Brno University of Technology, from the Faculty of Business and Management. So on this slide, you can see the content of my presentation. First of all, I would like to introduce a little our department, our faculty, and our university. Then I will speak about some fuzzy modeling, so fuzzy possibilities, how to use the fuzzy models in project management. And then I will speak about some possible research in this area of the fuzzy modeling in the project management, and final the conclusion of my presentation. So I am from Brno University of Technology from the Czech Republic. Brno is the second biggest country in the Czech Republic. You know that the capital is the Prague, and Brno is the second biggest or largest city. There are a lot of universities, and one technical university is our university. Our university, Brno University of Technology, has 8 faculties, and one of the faculty is also the business and management faculty. So we focus on learning and research in the area of business, economics, and management. I am from Department of Informatics of the Faculty of Business and Management, but our Department of Informatics we can divide in 3 main sections. First is the mathematics and statistics. In this area, we teach the traditional subject like mathematics, statistics, applied statistics, and others. The second main area is the area of informatics. In this area, we focus on teaching the subject as information management, business intelligence, databases systems, data minings, and others. And the third area of Department of Informatics is the area of system engineering. And in this area, we teach the subject as operation research, soft computing method, but also the project management, knowledge management, and risk management. And I am the member especially of this section. So my research and teaching area is the knowledge management, project management, and also the risk management, and to use the specific quantitative method, so the quantitative approach for managing the projects, managing the risks, and others. So, why is it so important to use the new approaches, not only the traditional approaches in project management? On this slide, you can see some advantages of this fuzzy modeling. And the reason is that the project managers and also the another members of the project teams use very often the white terms as a small, middle, high, etc. in their daily use during the managing the projects. They use these vague terms in different areas. For example, in the area of the time analyzing of the project, risk analyzing of the project, cost analyzing of the project, and others. And they use these vague terms during all project management cycles. So we can say that they use these terms in pre-project phase, in project phase, concretely in the phase of planning the project, then in the phase of the managing or realization of the project, and also in the final phase, and this is the post-project phase. Of course, we use these vague terms not only in project management, but we can say that we use these terms general in management. That's the reason what we can describe these vague terms using the fuzzy modeling, concretely with the fuzzy set and the fuzzy numbers, because the degree of membership function of the fuzzy set determines us how much the elements belongs to the fuzzy set. And we can use this fuzzy mathematic approach for modelizing these processes in project management. We can use, of course, different types of membership functions like the triangle, trapezoidal, and others as a user. And if we use the application, the fuzzy logic, at this moment, you know that this fuzzy logic practical use, we can divide in three basic steps. First is the fuzzification, second is the fuzzy inference, and the third is the fuzzification. Fuzzification means that we transport the real variables into the linguistic variables. So we use some number of attributes. Then the second step is this fuzzy inference, and this in this phase we must set the set of the linguistic fuzzy rules, the traditional rules of the type if something, then something, or another types. And finally, the third step of the defuzzification. In this step or in this phase, we transfer the results of fuzzy inference of the output variables back to the linguistic value of is it possible also to the value of to the number value. So it was only very shortly something about the fuzzy logic, because I will use this fuzzy logic approach in project management for evaluation, for example, the success of the project and so on. Before starting the speaking about the fuzzy modeling and their application in project management, it is good to speak about the current state in the area of project management modeling. I realized research on this area, which was focused in the Czech Republic, and you can see on the left chart that there is quite no problem to use the traditional tools and method and techniques for managing the project. The project managers use very often, for example, the Gantt chart for the time analysis of the project. Also, they work with the network diagrams, and thanks to these network diagrams, they apply the traditional CPM method for the time analyzing of the project, but they use not so often the PERT method, and then you know that the PERT method is the stochastic method, so it's the stochastic model based on the probability and statistic, but they don't use this method so often. Equal is it recommended from the special organization in project management, for example, the International Project Management Association, and so on. Also, you can see from this chart that there is a huge problem in the area of risk management. They don't do, or they don't not so often evaluate the project risk, and we can ask what's the main problem or what is the key problem why they don't use it, but probably it is the reason that they think that it is not necessary to do it because some type of the project they think that are the repeated project and it is not necessary to do it. But I think that is a huge mistake because the risk management of the project is one of the main area in project management, and not only in project management but general in the entrepreneurship projects. On the right side of this slide, you can see some factors or reasons why the respondents evaluated their project like unsuccessful. You can see that very often they have a problem with the time management of the project. So very often the project was have a delay. And the second huge area is the budget of the project, so the cost analysis of the project, that the main factor on the reason of unsuccessful the project was the situation that the project was evaluated over the budget according the plan. The third big problems with the success of the project was the communication in project teams and also the changes of the attributes of the project's sponsors. If you want to see more details about the main results of this research, so this research which was focused for identification the level of use modeling in project management, you can see my publication. And now I would like to introduce you one possibility how to use the fuzzy modeling, completely the fuzzy numbers in project management. And this is in the area, this is from the area of time analysis of the project. You know that we can use for time analysis of the project the traditional CPM method. So the critical path method for identification the critical path of the project. There is a problem because this CPM method is the deterministic method. So we work with the deterministic values of time duration of each activity in the project, and this is not so often possible to do with these deterministic values. Of course, we can use the stochastic model. So, for example, the PERT method for this time analysis of the project. At this moment, we can work with 2 or 3 time estimates, like the optimistic time duration, pessimistic, and most likely duration of the activity. At this moment, we can also use the simulation, for example, the Monte Carlo simulation in this situation and others. But I think that one of the best way how to identify the critical method is based on the fuzzy numbers. So we can use these fuzzy numbers for describing the uncertainty of time duration of the activity. From this table, you can see, or in this table, you can see some case, some small project which has 14 activities. These activities you can see in the first, second, and the third columns. First two columns identified as the nodes, the inputs and output nodes. The third is the name of the activity. The next column is the time duration. But now it is better to describe this uncertainty in the time duration thanks the fuzzy number. So we will not speak that the duration of some activity is, for example, 5 days or 5 weeks, but we can speak that the time duration is about 5. And this uncertainty we can describe, for example, with 3 fuzzy values. So we will use the triangle fuzzy membership function, and these we can of course express them in mathematic form, which you can see on the right side of this presentation. There is a case for the mathematic expression of the fuzzy number for activity A, which has the you can say the estimate from 2 to 6, and the membership function on the level 1 is 5. And then you can see also the mathematical expression for the activity E, which is also about 5. The time duration is also about 5, but the next numbers are another. So this is the first possibility, and then when we apply the basic, you can say basic process of the CPM method for calculation or identification this critical path. So we can divide this process in 3 basic steps. First is the calculation of early starting times, completely the time characteristic as early possible start time of the activity, earliest possible finish time of the activity, and this activity we can calculate using the forward pass. And you can also see the formula, how to do it mathematically. It is not so problematic because you only use this mathematic formula when you take the earliest possible starting time plus the duration of the activity, and with this way you can calculate the earliest possible finish time of the activity. Second step we call the backward pass. Thanks this step we calculate the latest finish time. So completely we identify the values of the time activities like latest possible start time of the activity, latest possible finish time of the activity. You can also see the basic formula how to do it, and thanks this time characteristics, we can then calculate the final characteristic, and that's the flow. So completely the total flow. We have also another type of the flows, but the total flow is for us the most important flow because we can identify the critical activity based the value of this total flow. So the general formula is when the total flow equals 0, then this activity is evaluated as a critical activity, and the set of the critical activities identify the critical path in our project. So that's the main advantage, how to apply these fuzzy numbers for identification the critical path in our project. On this table, you can see the results of the time analysis using fuzzy approach based on 3PM method for our case. So for our case, which has only 14 activities, you can see the calculation of the time characteristic, like the early starting time, latest finish time, and the value of the total flow for each activity of the project. And on the row, which are colored with the green color, you can see the activities which were evaluated as critical. So the set of these critical activities is the, you can say, is the critical path in our project. This application of fuzzy modeling in CPM method or another, so in this method which we can use for time analysis method, is, we can say, nothing new. There are a lot of publication on this topic, but still this approach is not used in daily project management practice. What's the reason? I think that one of the reasons is that there is no software support how to do it automatically, and when this software support doesn't exist, this is very problematic to use it from the point of the project managers and another team and other members of the project team for their daily use. The second possible area how to use the fuzzy modeling in project management is in the area of the quantification of project risk. So now we are in the area of risk project analysis. It exists a lot of method for managing the project risk. One special method is the reprand method. This method was developed by Associate Professor Branislav Lasko from the Mechanical Engineering from our university. And this quantification will be focused based on the principles of this reprand method. So this reprand method has 1, 2, 3, 4, 5 basic steps. First step is the preparation for the risk analysis. It is quite important phase because in this phase we must identify who will do the analysis of the project, how often we will do it, which way we will use for quantification of the risk, because very traditional we will use the qualitative approach. Sometimes we can use the quantitative approach, but that's the reason why we are also not so possible to use this quantitative approach so often for evaluation, because we are not able to identify the concretely deterministic values, for example, for the criterion probability. Because the project managers have very big problem to identify deterministic, for example, that the probability of something is 0.765 and so on. That's the main problem. Second phase of this reprand method is the identification of the risk. This phase is based on the identification of the threats and the scenarios. The next step is the quantification of the risk, and this is my topic. And in this area, I would like to recommend to use the fuzzy logic for evaluation of the risks. So we will work with traditional two criteria. First is the probability, and second is the impact of the project. The next phase is the response to the risk. So that's the area of the risk treatments. So which is the best, you can say, measures to minimize our risk. And the final step in the reference method is the general assessment of the risk. So in this area, we can say evaluate again the overall value of the project risk after the implementation some measures. So the fuzzy model of risk quantification we can apply using the fuzzy logic, and this picture you can see that we will work with two inputs. First is the probability and second is the impact of the project. We will work with one rule blocks and one output variable. An output variable, it will be the risk value, so the overall risk value. We will use the Maulana's fuzzy inference method for modeling this topic, and I use the fuzzy logic toolbox in MATLAB for creating the fuzzy model for risk quantification in project management. On this slide, you can see that I will work with 5 attributes, which was set as attributes for inputs, but also for outputs variable. So we work with the attributes that the probability is very high or middle, low, or very low, and also the impact of the project is very high, middle, low, and very high. So if we ask some expert in the field of the project management, they are able to answer me that some of the probability on some sub-risk is on the level high, middle, but they are not able to answer me that the probability is 0.76 and so on. So you can see that in our model was used the trapezoidal Mandelson function for all inputs variables and also for output variable. On this slide, you can see the rule block. We work with one rule block and the rules. So the linguistic fuzzy rules of the type if then. So if the probability is evaluated as very high and the impact of the project is evaluated as very high, then the risk value is very high. We work with all possible combination on this 5 attribute scale. So the list or the set of the combination you can see in this table, and there is the basic setting of the combination. So you can see that over the diagonal are the risk evaluated as very high, under the diagonal as very low, and on the diagonal as middle. Of course, you can change this combination of the fuzzy rules. It depends on the project, it depends on the experts and so on. And on the right side, you can see the print screen of this linguistic fuzzy rules from the MATLAB fuzzy logic toolbox. On this slide, you can see the surface, which described as the relationships between the variables. So it's only the visible situation and described as the behavior of the system. For example, you can see that the coordinates with the number 0 and 0 represent the situation that the inputs variables probability or input variable probability and impact on the project are very high. At this moment, the output variable risk value is evaluated as very high. Opposite the situation, so the coordinates 1 and 1 represent the situation that the input variable probability and input variable impact on the project are very low, and then the output variable risk value is also evaluated as very low. So you can see that the inputs variables and outputs variables are, you can say, the functions, and described as the behavior of our fuzzy logic fuzzy model system. On this slide, you can see the risk quantification for some specific project. And you can see that the value of variables probability equals 0 and impact on the project equals 0 correspond with the first fuzzy linguistic rules. You can see with the blue color on the first row in this picture. So with this way, we verify the model, and we can say that it is general functional. The third possible situation how to use the fuzzy modeling in project management is in the area of evaluation of project success. So still there are a lot of publication. What is it, the project success? How to evaluate it? What are the main criteria for measures the project success and so on? So my approach was based on three areas. First area, evaluate the project status. The second, evaluate the project risk. And the third area, evaluate the project quality. These three areas were the main three inputs to the fuzzy logic model for evaluation of project success. In the area of the project status, I work with the nowadays recommended method for evaluation of project status, and it is the end value management. And value management and value analysis is the second name of this method. This method is based on several party indexes, but the basic indexes in this method are the SPI indexes and CPI indexes. SPI index means the schedule performance index, and this index describes as the situation if our project is before or over the time according the plan, and the CPI index means the cost performance index, and this index describes as if the budget of the project is if we are over the budget or under the budget according to our plan. So both these two indexes describe are the time analysis of the project and the cost analysis of the project. These two attributes are also the basic attributes which we evaluate in, for example, in iron triangle in project, and the third is the scale of the project or the aim of the project. So the second area is the project risk. This area is again based on the RIPRAN method, because this RIPRAN method, risk project analysis method, is the special method developed for analyzing the risk in project management. In this area, we specifically focus. In this area, in this area of application, the risk project analysis method focus to the final step, and this is the general assessment of the risk. This general assessment of the project risk is based on two criteria. First is the number of sub-risk, and the second is the total value of sub-risk. These two criterions will be two inputs in this section. And finally, the third area is, of course, the quality of the project. This is focused to the area of the aim and the scope of the project, and the evaluation of the project quality is based on the international standard for quality management, so the guidelines for quality management in project. So international standard with the number 10006 to 2017. And here we can identify that they use for evaluation of quality of the project two criteria. First is the degree of compliance with the requirements, and the second is the eligibility for use. And these two criterions I will use as the inputs criterions in my physiologic model for evaluation project success. So on this slide, you can see the basic model of evaluation of project success. You can see that each two criterions are evaluated in special rule blocks. So we have 4 rule blocks in total in this model. The first rule box, number 1, evaluate the project's status. The second rule block, evaluate the total value of the project risk. And the third, the quality of the model. And the rule block number 4, evaluate the final success of the project. So you can see that the outputs of these 3 rule blocks are the inputs to the final rule block number 4. On the right side of this presentation, you can see some comments or notes for these models. So how many submodels we will have, how many rule blocks we will have, how many variables we will have, like the inputs variables and also the outputs variables, and how many attributes we will use in our fuzzy model. So we will work with 5 attributes in all inputs and outputs variables. It was the attributes very small, small, medium, large, and very large. And on the next slide, you can see again the rule block, only the rule block number 4, so the final evaluation of the project success. You can see that we have 125 linguistic fuzzy rules, so like the all combination of these inputs. We again use the traditional type of the fuzzy rules on the type if something, then something. So if the project state is evaluated as very small, so it means that's the and if the total value of project risk is evaluated as very small, and if the project quality is evaluated as very large, then the project success is also very large, and opposite. Of course, you can also change or modify these fuzzy rules for specific projects. Here you can see again the surface. So on this surface, you can see the behavior of our fuzzy logic system, and this surface describes us if we well done describe with our rules all behavior of our system, so we can check it. And of course, you can see what represents the coordination, for example, with the value 0, 0, and opposite. Here you can see that we work with the 3D surface, but we have three outputs variables and inputs variables and one output variable. So some of them is fixed, and the next one we can change. On this picture, you can see the evaluation of the success of the project for some specific project. So with this way, we again verify our model. You can see again the situation on the first row that all three inputs variables equal 0. Then you can see that the first fuzzy linguistic rules work or were active with some value. And the interpretation is that if the project status is evaluated as very small and the total value of project risk of the second area is evaluated as very small and the third area of project quality is evaluated as very, very large, then the project success is evaluated as very large. Of course, it depends on some specific project, and if it will be necessary, we must change or modify all these fuzzy rules, because these fuzzy rules are the best or the most important rules based on our fuzzy system model. Now, I would like to introduce you a little the use of combination of some method from the areas of computing. So here is the neurofuzzy model for project state evaluation. Work with the combination of artificial neural networks and fuzzy logic. This project state is again based on the earned value management method. I have spoken about this method a little, so you know that the basic indexes in this method are the SPI index and CPI index. On the table in the middle, you can see some concretely value of this indexes SPI and CPI during some managing the project. So we have some concretely values, and these values were the inputs to our UNFIS system, and the aim was to identify the rules and the membership function, so the parameters based on this inputs data. On the chart on the right side, you can see the traditional visualization of this SPI and CPI indexes with the middle in the middle with the value 1. Value 1 is because that if this SPI and CPI indexes are evaluated or equal value 1, then all is okay. So according the plan from the point of the cost and from the point of the time. If there are the differences, there is some problems. So first, I must prepare these inputs values for the UNFIS editor, and this preparation you can see on the table below. So I will identify the deviation from number 1, we can say, for all these inputs values, and then I normalize these values into the scale or into the range between 1 and 0. That's necessary to do it for the preparing the inputs values for the UNFIS editor. On this slide, you can see the training process of the model. So I set the inputs, so the basic parameters for the models. You can see how is it with the error during the training process, how many epochs were used, and so on and so on. According this inputs data, we identify the parameters of our model. So we identify the membership functions and also the fuzzy linguistic rules based on this inputs data. So you can see how this membership function looks like on the pictures on the right side, and also you can see the relationships between these variables. So you can see the surface, and on the right side you can see some part of the fuzzy linguistic rules. So the rule blocks all is or all was all has all was done in the MATLAB concretely the fuzzy logic toolbox. Now I would like to introduce you the possible research and possible cooperation in the area of project management and the use of fuzzy modeling in this area. One of the biggest problems is still the assessment of the project risk. How to evaluate the project risk? It could be do using this fuzzy logic approach, but again, there is no special software which the project managers can use in their daily practice. Second biggest problem in the area of the risk management is the evaluation of the measures, so the treatments, so the trees, which is the best one. We know as a project managers that it is a huge problem because very often we evaluated these measures not according to one criteria, but very often more than one criteria. So we are in the field of the multi-criteria decision making, and in this field it will be fine to use for as a support for this decision making process some special method. So I think that one of the possible methods which we can use is the analytic hierarchy process. So analytic hierarchy process method from Professor Sati. But if I have spoken in the beginning of my presentation, that still is a huge problem to identify the deterministic value. So that's the reason why it will be fine to modify this analytic hierarchy process to the fuzzy analytic hierarchy process and apply this fuzzy analytic hierarchy process for evaluation these measures in the area of risk management in the project. We can do it in different types of projects. Nowadays are very actual the projects from the area of the sustainability. So the sustainability projects are very complicated. The project teams is international. So the project, the members of the project are in a lot of countries all over our world. Second possible area are the second specific projects and how to evaluate the risk which are connected with these projects are the cyber security projects and so on. And the second area where we can apply, for example, fuzzy modeling approach, but not only this, also another area is possible to use, is the problem with the project prediction. Nowadays, we can work only with some standard method for evaluation of the project status. This method is, for example, this earned value management method, but this is not the best method how to do the predictions of the future behavior of our project, how to evaluate the past, how to evaluate the project status, and how to evaluate the future. Now we are in the beginning of this research, and we think that one of the possible methods how to describe this issue of the project prediction is to apply the theory of fine and automaton and the theory of Markov chains. But that's only our, you can say, experience on the field of the theory, but how to do it much more practical. Now we are in the beginning. So my conclusion to the topic of the modeling in simulation in the area of the project management. We know that according the results of specific or some organizations which are focused, for example, to the project management as Ernst and Young, Standing Groups and others. So we know from the results of their research that there are still a large number of the projects which are evaluated as unsuccessful. Some of the reasons why the projects are evaluated as unsuccessful, I have spoken in the beginning of my presentation. According their reasons, there is a recommendation that it will be not possible to manage our project only with the traditional method. According to my research in the area of the level of use, the method in the Czech Republic, we know that there is also a problem with applying or with using the traditional method in project management. The traditional method, like the method of CPM, PERT method, Gantt charts, and other. So if there is a problem with this traditional method and their use in project management, here could be also the problem how to use practically this new method from the area of some computing, because the main aim will be to develop we can say the knowledge or expert systems as a support system for managing our project. And for example, the International Project Management Association speak that it will be not possible to manage the projects successful without the application of modeling and simulation. And the time is running. After the year 2025, that's, we can say, the deadline, and that's, we can say, one of the key factors to be success in the modeling, managing, and planning our projects. And it will be not possible to do it without the modeling and simulation in this area. Because if we have the model, we can do the experimentation and different kind of simulation with this model. So on this slide, you can see my publication, which are focused to the area of fuzzy modeling in project management. All are available on the internet, and you can also, if you want, you can see it and read it much more in detail. Some of this topic, which were described today in my presentation. And here you can see my contact details, and also you can see my link to my old publication. I think that's all, and thank you very much for your attention.
We can do this.
Thank you so much, sir. It was a very neat and meticulous presentation wherein step by step you have shown the analysis of the data and use of fuzzy model and neurofuzzy model in project risk management, and how the evaluation of project success based on fuzzy logic is done through the analysis of the project status, project risk, and project evaluation. You've also explained how the fuzzy expert system can be used for evaluation of the success of project making use of linguistic fuzzy rules. Thank you so much. We are, if you allow us, then we'd like to take up a few questions that some of our students are having. Would you mind? Can we take up the questions, sir? Professor, can we take up a few questions? Hello? Sir, can we take up a few questions? Professor Ravik?
You can take a...
Okay,
Yes.
okay. Okay, yes, please, you please unmute yourself and ask your question.
Excuse me, the presentation was so far. So nice way he has presented all these things, but however, I have a query, some query, because I am very new in this field. First of all, fuzzy numbers have been used in the summation and difference. The presenter has considered maximum and minimum, right? So, would you like to tell me how you have defined maximum when you considered summation of fuzzy numbers, and accordingly minimum when you consider difference of fuzzy numbers?
So yes, of course. So if I would understand your question, there was the problem how we identify the minimum, so the scale in the area of the fuzzy modeling and these topics.
Yes, yes.
Yeah, we use one of the traditional approach because we work only with, we can say, 5 attributes on the 5 linguistic values, and they were, we can say, linear distribution for this minimum and maximum level on the scale from 0 to 1. And because the fuzzy rules was identified only, we can say, artificial, based on some expert, but we were the expert. If the expert said another, then we change the membership function, depends on this fuzzy rule, so it will be visible not so nice fuzzy membership function in all this distance, but it must be changed. So at this moment, it was only the basic model of the principle how to do it as a for the evaluation of different areas, and that's what the reason why we work with this basic scale from 1 to 0 or opposite, and each membership function, trapezoidal or another membership function, were used with this way. If we have some concretely data and we can identify the fuzzy rules from this data. So that's the main problem, to have the inputs data from different topics. And if we have this inputs data, then we can use, for example, another approaches. And at this moment, we can change this inputs data, identify another membership function, and so on. So thank you for the question. That's what it is.
Thank you. Sir, one thing I had worked on human health risk analysis, but in case of risk analysis in project management, in which step the uncertainty arises?
Which analysis do you mean? Human?
In which steps of risk analysis?
No, sir is asking in what is the name of your topic, the paper in which you have worked?
The name of the topic?
Human health risk assessment. Human health risk assessment.
Human health risk assessment.
Human risk assessment.
Health risk assessment. Human health risk assessment.
No, that's a little another area. It's quite complicated because again, I focus to the evaluation of the project risk, but general the entrepreneurship risk, because I am from the faculty of business and management, and we know that the risks are the problems, how to solve not only the projects. So the general criteria which we use as inputs variables for evaluation the risk are the well-known criteria as a probability and impact of the project. And I think that these criteria we can apply also in another areas which are focused to the risk management in general. But still, there is a problem with the quantification, because generally we can work with two possibilities ways: the numerical quantitative evaluation or the qualitative evaluation. But qualitative evaluation doesn't equal fuzzy logic. Fuzzy logic is the uncertainty, and we work with all these negative functions is not the same as a qualitative evaluation of the project risk. And in our rates, there are a lot of topics and a lot of categories how to evaluate it, from the marketing, financial, distribution, human risk, and other in this.
Right.
Yeah.
Thank you, sir.
Welcome.
Thank you so much, sir. And I think though we are having several other questions, but because our next speaker is already waiting,
Hello,
so
sir.
yeah, we will be Shamo.
Hello,
Shamo,
sir.
you okay, Shamo.
Hello,
Okay, sir.
sir.
One more question, last question from Shamo, sir.
Yes,
Okay,
sir.
Shamo, please
Sir,
put on.
first of all, sir, thank you for giving a brief insight about the project management and the fuzzy logic. I'm not from a project management background. I have a certified in Six Sigma black belt, but I will like to ask one question since I'm working about the type 2 fuzzy. Sir, in PERT, that is part evolution review technology, can we apply type 2 fuzzy? And if yes, how can we find its TRIPS value?
Yes, I am. Thank you for this question. That's a good question, because I think that all these areas which I have a little described, it will be possible to transfer to the use of the type 2 fuzzy. It will be fine if we can do it, and to do this cooperation and this field, for example, with you or with our colleague, Professor Deepak Kumar Jana, because he is an expert of this two-type fuzzy modeling, and it will be fine, because at this moment we can do it much more better, because this two-type fuzzy logic approach is better for describing this our economic system, and this economic system are full of these vague terms. You know, we are very often not able to work with this deterministic value. That's the main problem. Yeah, thank you.
Okay. Thank you, sir.
Okay. Okay, now I think we'll have to move on. And sir's session was so interesting that we are having so many questions. But because we are having a time constraint, so I would request our program chair and also the session chair of this first session, Professor Radha Vallabh, to kindly say a few words so that and grant us the permission to move on to the next speaker. Radha Vallabh, sir, now over to you. Sir, please unmute yourself. Radha Vallabh, sir, please unmute yourself. Sir, please unmute. Sir, please unmute yourself. So switch on the mic. Just click on the that particular mic icon. No, not yet, sir. Radha Vallabh, sir, not yet. No sound. So just unmute yourself. Kindly unmute yourself.
Some technical.
Yes, I think there is some technical issue.
Yeah. Okay. Priyanka ma'am, please move forward.
Okay. I think Radha Vallabh, sir, is having some technical issue. Sir, with your permission, we are moving on to our next speaker.
One more line I want to add.
Yes, definitely.
Towards Professor Doskosil Radar. Actually, in my opinion, I want to share with you. We have studied and we are teaching the part and CPM. This problem we are using in our practical life, but we never did in the fuzzy environment. So when I've seen the professor group has doing these things, it's amazing, and it's a good work. So once again, if professor you allow in future our group, we will do some fuzzy type 2 fuzzy or type 3 fuzzy. So it will be help us.
Yes,
So Madam
thank you
Priyanka,
very much.
Madam, thank you.
Yeah,
See you.
it
Hope
will be
see you
fine.
very soon.
Very soon to see you face to face. Thank you. Bye.
Thank you. Thank you.
Okay,
So
now, so with everybody's permission, I am moving on to our next speaker who is already here. And now we are going to have in this particular session, Dr. Polash Dotto from the Department of Mathematics of Dibrugarh University, a reputed scholar in the field of study, to chair this session. And now we would move to Dr. Roman Sanarik, who is an associate professor in the Department of Applied Informatics and Artificial Intelligence of Thomas Bata University in Zlin, and he's also the head of the AI lab. He has expertise in controlling performance measurement, performance management, human resources management. He is a member of several teams working on grant-related tasks, scientific research projects, and analysis performed for industrial manufacturing enterprises in both the Czech and Slovak republics. He has been working in an interdisciplinary area applying natural language processing and artificial intelligence in management, and some of his interesting research articles very nicely bring that out. For instance, if you allow me, scouting of whiteflies in tomato greenhouse environment using deep learning, malware classification by using deep learning framework. How does the number of object function evaluations impact our understanding of meta-heuristics behavior? Efficient image retrieval by fuzzy rules from boosting and meta-heuristic, and so on. So if I go on reading out the number of papers that he is having and he's working on, the whole session would be over. So without allowing much, I would now request Dr. Sanarik to deliver his speech. Over to you, sir.
Okay, thank you very much for introduction. Okay, so let me just start with the presentation. Okay, so just sharing the screen. Okay. So, well, I suppose that you should see my screen.
Yes, sir. Yes.
Right?
Yes, right.
Okay, perfect. So there should be the presentation. So again, thank you again for introduction and for invitation to speak this workshop, or let's say a really nice meeting of scientific experts. Well, the topic will be maybe a little bit different from the topics that have been presented in previous days and in previous sessions. Well, today I would like to, let's say, connect two topics. One is evolutionary computation, and one is machine learning. I just want to find out, or I just want to show you where we can join these things together. So where we can basically find some interesting things that connects evolution computation and machine learning. We can say where machine learning meets evolution computation. So, well, I can skip the introduction because well, there's more words that has been said about me. Just to some few things. Well, I am the chairing the evolution computation research group, and I'm which means automated machine learning, and finding tuning of hyperparameters of machine learning system by means of symbolic regression or evolution computation. And we can easily get to the outline of today's talk. Well, I'm quite aware that we are like 50 minutes behind the schedule, so I would try to be quick and in comprehensive form just to deliver the talk. So firstly, there will be a really slight background into the evolution computation techniques and what current problems we are facing in this let's say field of research of meta-heuristic algorithms and ECT. Well, I will just show you some few solutions.
Excuse me, Professor, your screen is not visible. Your screen is not visible. Your screen is not visible yet. Please reach it.
Okay, so this is typical Google Meet and the Mac. Okay, so I will try to do it again.
Yes, yes.
Okay, so I will maybe to share my whole screen and then to switch somewhere. Okay. I don't know if something is happening. Now, can you see my screen?
Yes, sir. Yes, sir. It's fine.
There should be outline of presentation and some few points.
Yeah, yes, sir. Yes,
yeah,
sir.
Now it's fine. Okay.
Yeah.
Sorry. This is typical, you know, that MAKAUT absolutely hate Google Meet. And well, just where I just finished, so I just show some solution for recent advances and some few examples how we can, you know, tackle these problems. And I later will show you some interesting benchmarking things that are related to machine learning and evolution computation and some future challenges and direction of ECTs. Well, so just make things quick. Well, just start with the background of the evolution computation techniques. So basically, maybe some, I suppose that most of you are aware of or very well know the meta-heuristic algorithms, this iterative optimization techniques. Well, but where's the motivation for development of ECTs, and where was the motivation in 90s and later in next years? We can say that, of course, the nature-inspired algorithms, and nature is the greatest source of inspiration for the experts and researchers. And well, this is where we firstly, during this talk, we connect the artificial neural networks or machine learning with evolution computation. Well, because if we just ask a question, you know, what is the most famous and let's say the best solver of the problems in nature, of course, it's a human brain, which was the inspiration for neurocomputing or basically ANNs, and then later for all this deep learning stuff and so on. And basically, and then we just need to go more inside and ask a question, you know, what was the inspiration or what created such a human brain that is a very good solver? And of course, it was the evolution. And in many iterative steps, basically the nature evolved, you know, the really smart system. So that was the inspiration for evolution computation techniques or the algorithms. And that can really cooperate with the artificial neural networks machine learning. Okay, of course, if we just spend a few words about the ECTs, in computer science, you know, these ECTs are the subfields of computing and AI. Of course, it's very difficult to, you know, find out where's the correct position in this AI paradigm and universe, but it's part of the supercomputing. As Professor Lofty Zadek defined, you know, this umbrella for evolution computation, fuzzy logic, and then neural networks. So this is this part of this, you know, really big group. And we know that some complex optimization problems, which, for example, can be also the finding of hyperparameters for the net or for machine learning systems, these can be unsolvable by traditional determinism methods with the limitations of computer technology in the, let's say, time that we consider that we want to invest and the money for the energy. And of course, these meta-heuristic methods, you know, usually often find the solution in very good time. You know, of course, but there is no guarantee of optimality. That's why maybe some people don't like these techniques, but this is natural. You know, if I cannot give you the proof that this method will sooner or later converge to some, point that, of course, it's of course nature that you not believe me that it's I can reach the good solutions. Well, just to conclude this introduction, we know that the evolution techniques are inspired by Darwin's principle of nature selection, and of course by the key mechanism of evolution of Mendel's law of heredity. It's a very famous researcher that comes from Brno, so also from so it's very close to also some invited speakers from Brno Beauty. Well, and we are using the iterative process that simulates the population evolution and evolution of better solutions. We use some special operators to control the evolution process, so mutation, crossovers, and some spatial selection and checking of diversity of population and finding and just keeping the population diverse and balance between exploration and exploitation. And this is something that is done in classical algorithms, also in special type of the algorithms, because furthermore later, especially in the late 90s and the beginning of millennium until maybe 2010, there was many subswarm algorithms introduced, which are using the patterns of collective intelligence, for like flocks of swarm or birds and fish and insects. And this is also very, very popular because these swarm principles are also used in the swarm robotics, because it has a very big advantage because there's no command and control unit. Everything is based only on local interactions, so we don't need to control the, let's say, the spreading of the intelligence and so on. It's basically something similar to multi-agent systems, but there are some slight differences. Well, if I just conclude this talk with some taxonomy, so you can find in evolution algorithms, genetic algorithms, these two are usually mixed. That someone say that, the GAs are that part of the EAs, but someone say no, GAs are not EAs because the GAs are something standalone, because it was reintroduced or reincarnated based on the ideas from Turing and Baricelli in later 60s. And then, 20 years later, the EAs have been introduced. We have very famous genetic programming and evolutionary programming, and as a part of the symbolic regression. And of course, these swarm intelligence form algorithms, and of course, many different things like hybrid algorithms and hyperheuristics. The hyperheuristics is sometimes used or sometimes is changed with the meta heuristics, which is not correct. That like a meta evolutionary or meta evolution, which means that we are using the evolutionary algorithm to find the hyperparameters for another evolutionary algorithms. Well, the advantages. So basically, this ECTs generally allows to solve the complex optimization problems. And these algorithms are used in many branches of human activity, especially in engineering, informatics, like, some finding of good position or placement of for example, some routing points, or, the optimization of tasks and scheduling and whatever. In industry, transport, medicine, so many things, many ways we can apply these techniques. They are general purpose and widely applicable. Basically, what is very nice, they basically work in a black box mode. We just need to know what is the quality of the solution. We just need the evaluation of the solution. And we can also produce the alternative solution, which is very nice, because sometimes, these algorithms can produce the solution what normally we will have no idea that they can exist, because people just simply, maybe we are not, as humans, we are not so, let's say, creative in maybe some sort of a little bit, some crazy form, that we will just simply say, oh, no, this cannot work, because if I just take these parameters like this and that, it never can work. But these algorithms can show you that if we just combine some really parameters that are like on the edge of our imagination, that we can get some good solution. And of course, these algorithms can be very easily utilized and can be implemented in HPC platform, and they are very good and successful in practice. But of course, not everything is sunshine and rainbow. So it's just a suboptimal technology. As I already said, there's no guarantee for quality of solution. Basically, I cannot simply just tell me how many times you can just ask me for giving some proof of convergence, something like that. I will simply say, sorry, I cannot do that. Maybe in some really really bounded, scenarios. I can do that for maybe general algorithms or some special types of discrete optimization problems. But basically, otherwise, I cannot guarantee the quality of the solution. It's computationally demanding technology, of course, because if we are solving the problems with many parameters, multi-criteria stuff, it's still computationally demanding, no matter that basically the enumerative way of computing, I mean, the brute force computing will take more, maybe like 10 times the age of universe. But here we still facing the problem. It's still demanding, so we cannot just speed it up very much. And of course, it's necessary to properly set the parameters of the algorithm or to understand the parameter adaptation process, which is difficult sometimes. And this is the very same in machine learning. This is the very same in neural networks. So basically, we need to, set the hyperparameters. We need to learn the network and so on. So it is very similar. So we need to set up the learning system, the adaptation system, set the parameters. So we need to have maybe some a priori knowledge about the problem, how to finally do that, and so on. And of course, there's insufficient theory on understanding of the methods. Well, the situation is becoming better and better, but still, we don't have many theoretical stuff related to this type of the algorithms. We still know that there's an free lunch theorem, which means that basically the algorithm is perfectly for problem A, but absolutely failed on problem B. So we don't have this, golden universal algorithm. We are missing the runtime analysis. We are missing the complexity measures. We are missing many things that are maybe common in different intelligent computing techniques. Well, and just look at the current problems in cities, and then we will just move to some solutions and then benchmarking and connection with the machine learning. Well, the first problem currently is that there are too many new algorithms. This is maybe also some sort of self-criticism myself, because we also started with the nice idea, okay, let's develop a new algorithm. Of course, this is nonsense, because there are many algorithms already developed, and the many, let's say, new are introduced every day. And that's why, for example, that there was evolution computation bestiary introduced, where basically the researchers are, let's say, storing in this library the algorithms that are only mimicking some metaphors from the nature, and basically they are not moving or pushing the theory or development of these meta-heuristic algorithms, optimizers, and connection with some different AI stuff further. So if you can see, there are like thousands of algorithms already there, and it doesn't make many sense to just create a new algorithm, because you see also that it's dropping down, this gold rush, for the new algorithms. And it's why, and maybe you can ask why it's so dropping, because till 2012 or 13 or 14, it was very easy to publish in any journal. You just simply start your title with novel meta-heuristic algorithm, just put there anything, like squirrel algorithm or, fly algorithm, whatever. And usually it gets through the review process, because it looks maybe some promising. You introduce some benchmarking results, and that time there was basically no benchmarking rules, so it was really like a wild west. So it was difficult. And for example, here you can see this criticism of new algorithms. That is the second problem currently, that there are, as I said, many new algorithms that are not really new, but then they highly cited, which is interesting. That you can get, you can create we can say some metaphoric algorithm. Sometimes you can get through into some very good journal, and these algorithms are usually highly cited, because everybody just simply say, okay, that's a new algorithm, just look at that. Okay, I want to compare the result with these new algorithms. You can get easily hundreds and thousands citations, and even though it's like the algorithm is nothing special, but also this criticism of new algorithm is because the poor quality of experiments, especially in selection of competing algorithms, because the people that are producing these new algorithms usually compare the algorithms with some 1995 versions of standard, very old versions, and so on. And they said that problems that will be biased, to their own algorithms, so they can always win and so on. And the thing is that, what I already mentioned in maybe previous slide, the reviewers automatically reject the papers without the reading of them. So usually if you start the paper with, I'm using a new meta-heuristic algorithm, that usually this paper got rejected automatically, not matter what is the content further on. So just you should be very, very careful about this. And there was really two famous papers, especially from Serens and Kenneth, this about the metaphors, the meta-heuristics, and maybe about this running away from the bio-inspired tsunami. And you can find these papers on Arxiv or somewhere on the Google. And what is the next problem of evolution computation techniques? Of course, it's the stagnation in local optimum, because these algorithms they can, sometimes they are designed for global optimization, but mostly they usually end their work in some local minimum. But we are maybe sometimes happy that we find some good solution in low cost with some reasonable time and some invested computer time. Well, but the global optimum is somewhere far away, and we just want to find them. But how to do that? How to avoid of this problem, and maybe just to use these algorithms for some really, really complex tasks, which is, for example, neuroevolution, or some tuning of really some complex demanding hyperparameters problem finding. Well, just look at this. What are the solutions? What are the recent advances in type of meta-heuristic optimizers? Well, the first thing is that we can ignore the criticism. Of course, we wouldn't like to do that. Or, should we stop the development? Of course, no, because there was a huge invested, let's say, time and the effort of the researchers already to meta-heuristic algorithms and to these really smart optimizers. And of course, that we can say that currently that there's this ECT winter around. Well, it's very similar with the neural networks, because from, I don't know, 1995 till 2005, 2010, there was this artificial neural network winter. There was nothing new extra, and that everybody say, okay, we already invented everything, and so on. And then, of course, Google DeepMind and this deep learning came to the stage. So then everybody switched to the deep learning and machine learning, and currently now the ECTs have been it was a hype in 2010, 2000. Currently now it's again everybody's focusing on machine learning, but we should respond to these problems in ECTs to maybe let these things make better and use them for machine learning approaches. So we should maybe reflect the criticism and find a way how to do that, and how to respond to the problems that are currently, let's say, has been discovered and described in evolution computation. So just to follow some recommendations for maybe development and improvement of meta-heuristic. So you should target the development on current issues, so not for something that was like 10 years ago, 20 years ago. Do not expand the bestiary, but of course, investigate, to develop, to analyze the current algorithms and try to push them to work better, to be more elastic, to be more robust, to work, say, more efficiently or effectively get some results. And how to solve this stagnation problem. Try to investigate in some adaptive parameters, some subpopulations, diversity measures, some communication, some parallel models or parallel models, and of course, to share the source code. This is the most important thing, because if you share the source code, usually many researchers around the globe will just simply find maybe some problem there, maybe can start to talk with you and say, okay, I have found some interesting solution to the code you have shared, because I think that maybe if you improve this part and so on, and of course use the proper statistical tests This was the biggest problem in 2010 to 2000, maybe 15, 16, 17, that the people simply say, okay, I have a better results, you know, and just show the tables with some average results and maybe some other median and some standard deviation. But this is not enough. I just need to show with some really proper statistical testing that there is some significant statistical improvement. This is the very same as in machine learning. You can just simply say, okay, you know, my precision is about 0 point something better. And that's all. You know, you should show some confusion matrices and some recall, sensitivity, and all this stuff, and maybe some different statistical testing report. And of course, the fair comparison of the algorithms with tuned parameters. And you just need to explain the selection of test problem, explain the parameter setup. This is also missing in the papers, and that's why maybe they can really easily get rejected. So basically, you have to explain everything. So the experiments will be very simply and easily, let's say, will be very easy to repeat for the other researchers. Okay, so you can find more info about this, for example, in this paper from this is from 2020. So this is nothing. So it's quite new. This fairness in bio-inspired optimization research, and this is really important, you know, from this Francisco Herrera and Maulana, because they are researchers that are standing for many interesting frameworks for optimization, or not only by optimization. And you can find some info there how to, you know, make some fair comparison of the algorithms on some problems and how to publish. And here I'm just showing the table. This is from 2019, because every year there's a CEC, IEEE CEC Congress on Evolution competition, and there's always a competition, let's say, for the benchmarking competition between the algorithms. For example, in 2019, there was the leading algorithm was JDE. The JDE was from 2006. So what the authors do is that, okay, basically it's written here. Oh, sorry, maybe it's okay. No. It's well, sorry, it's here. So the thing is that the authors take the algorithm from 2005 and really look at it and really cleverly change a few lines of the algorithm and retune it to the year 2019 and really absolutely break all the benchmarks and so on. So they didn't develop something new. They basically are completely new from scratch. They just take the old algorithm and really look at that deeply and say, okay, let's improve this. Let's get some smart, clever technique for, you know, the communication between some solutions. And wow, they just won the competition. For example, in our department, I just want to show you the first example. In one department, in my department, we just take this dish algorithm. I will just scroll back. Here you can see that it's on the 2nd place and also on the 7th place. Out of, there was, I think, 38 algorithms. This is just the first half. And we just improve the one line of the code. We just say, okay, this algorithm was targeted by the gradient. And we say, okay, why the gradient only? Let's just also focus on the diversity, on the, let's say, the distance between the individuals. So let's keep the individuals or the solutions a little bit diverse and distant from each other. So we just change one line of code, and we also almost win the benchmark. So there's no need always to develop something new. So there was a really boost of performance, and especially for large scale problems, which is maybe finding of hyperparameters of the networks. And we really improved the performance of the algorithm. So basically, it can be found here in this SWAVO journal, this state-based parameter adaptation for this success history-based differential evolution, which is a very interesting algorithm for large-scale problems. There's another example. This algorithm was the 4th place. Again, the Soma, self-organizing migration algorithm. This is the algorithm from 1991. And together with the researchers from Statistical Institute of Kolkata in India, we improve this algorithm with some organization process. So we just reorganize how the individual solutions are being selected for these comparisons and this crossover, mutation, communication between each other, and maybe trying to find some different nice spot in the search space. So we, again, 18 years old algorithm that has been improved with some very smart and clever technique. So I see that even 1999, okay, 1999 so was the releasing of the algorithm, and 2001 was the first publication. So you can also see more there in the publication on the webpage of Soma algorithm. So we just almost win the benchmark, you know, with this. And again, I already mentioned that there was just in this JD 100 winner, there was just some small change in organization process of the original algorithm to 2006. And just to tackle this issue with some proper statistical tests, again, if someone of you are interested in optimization algorithms, tuning meta-heuristics, or using of meta-heuristics for real problems, always please, you need to, if you compare your algorithm with some different algorithm, you always need to use this pair tests. If you have two algorithms, this Wilcoxon sign or sum rank test, it depends on whether the initial population or is the same for all the runs or different, or use some Friedman rank or some different tests with some Pozos tests like Bonfer and so on. Or you can use the deep statistics. This is very interesting, and also some of you who are related to statistics and for comparison of performance of the algorithms, the networks, there's a very interesting paper from my friends from Slovenia. It's Tome Eftimov and Petr Koroshev, and they released some different way of how to look at the results of the performance results of some methods and how to compare them. Not only based on, let's say, maybe some ranking or based on the median or average or standard deviations that can be just calculate over, let's say, 30, 50 executions, but they also look on the distribution of the results and so on. So this is very interesting for these deep statistics for, let's say, comparison of performance. And of course, this proper statistical test has been published again in 2020, so last year in this Forum Evolution Computation. And now we are just moving to the benchmarking issue. So how to compare the algorithms, and then we will just get to the future challenges and direction of ECTs, especially in connection with machine learning. Well, the benchmarking of ECTs, so again, it's required for publication. So if you want to publish, okay, I have improved the algorithm or I have used the algorithm, you should always compare your result with the latest state-of-the-art techniques and also with some historical results. So you can use the CC competition or Gecko community benchmark, Coco platform. There's a very nicely created IOH profiler. You can find it in its iterative optimization heuristics profiler, especially for discrete problems, and more on development. If you are interested in benchmarking or trying to push the performance of the meta-heuristic optimization algorithms more and more, you should check the IEEE CIS, this Computational Intelligence Society Task Force or Benchmarking Network. And there are many, there is a lot of interesting information there. So, and of course, you should follow the best practices and open issues. So this is the paper that has been published again last year. And if I just look at the names, I can see the biggest and best researchers in let's say mathematical optimization or subtle mathematical optimization that is related to meta-heuristic optimization and iterative heuristics and finding of hyperparameters for many interesting things. Well, as I already said, you can just Google the benchmarking network. It's on the Google site. Or you can just check this IEEE CII's benchmarking task force. So, how to find out the best ways how to compare the algorithms. And here we have these future challenges in direction of SETs. So what are the current trends in evolution competitions? And the question is, like, do we need constant development? Of course, yes. And why? Because there's an no-freedom theorem, which I already mentioned, that basically we don't have any universal algorithm that can work perfectly in, let's say, many or robust in many scenarios. We always have the algorithm that is perfect on one scenario and fails on another one. So that's why we still need some development and get the algorithms to be more robust, more flexible, more elastic, maybe for the parallel execution to next year's challenges. And well, what are the challenges in ECTs? As I said, the formal proofs is missing. And runtime analysis, complexity analysis, there's basically absolutely almost no mathematical background available. And large-scale problems, especially in connection with machine learning and maybe the tuning of hyperparameters, or finding the hyperparameters of the network, because we do know that there's always the curse of dimensionality, that more and more dimensions, we are going to scaling up to thousands and thousands. Basically, these algorithms have a big problems to work because they cannot find out, what's the difference between the solutions if they just simply differ in just few dimensions and the rest of the solution is the same. Maybe the cost function is the same. They are completely on the different points in the search space. And as I already mentioned, this evolutionary machine learning, this is also the really nice topic in the last years. And of course, as I already said, most of the focus is to discrete domain, because here we can create some proofs because we do know where exactly we are on the solution. Because if we have some, I don't know, 1 max problems where we're just trying to find the solution where only once in binary vectors, if we have a maybe 100-dimensional problem and we already have 85 ones and 15 zeros, we basically know that we are on the 85% of the good solution, and we know how far are we from the best. But if we are solving the real challenge from the technical challenge, or we are trying to find some good hyperparametric settings for some machine learning system, basically we have no idea where is the good solution and how far we are. Well, there's many problems that sometimes there was the frameworks like this parameter-free ECTs, but this is a nonsense, because every time there's something that you need to set up, and the people are of course scared of ECTs because they do not believe that work. And there's a huge contrast between the theory and practice. And there's a nice challenge how to bridge the gap between the theory and practice and show that these techniques can be really useful in real technical challenges. And this gap can be bridged by a very interesting and very easy solution. Just these algorithms should be simplified and keep them robust, fast, effective, and easy to implement, and not to add some extra features. I think that this will be also sooner or later will be a big problem also for deep learning stuff, because the deep learning started with some very bright idea, and then we moved to some autoencoders and maybe some attention gates and whatever. And currently, if I just open the paper, any paper about deep learning, I can just see some, randomized ensemble hyper-encoder model for this and this, and then this is almost impossible to implement for someone in real practice. So although these things should be simplified and easy to understand, but still keep them fast and easy and fast. And of course, we need to find some research, and we need to do some research in formal proofs and runtime analysis. And of course, we need to have some benchmark reflecting real optimization problems, because also this is interesting stuff. And you can ask the question, is there a real problem for optimization? Or is it just some artificial problem that I created because I opened the journal paper and see, okay, they solved this by, I don't know, some linear programming technique or some mixed integer, and just, okay, I just want to solve it with some heuristic optimizer. So it's still a real problem, or it sounds like that. So, this is very interesting questions. And of course, we need to have some synergy of point of view from engineering, from smart ideas, from maybe social science, electrical engineering, and so on and so on. And what are the challenges? Well, currently, these meta-heuristic optimizers, or these optimizers that are used by the, I think, one of the best researchers in machine learning, they just want to get rid of the gradient. And they just want to very get close to so-called general AI or human level AI. Because this type of artificial intelligence works mostly based on some instincts, context, experiences, not about the gradient. I just need to, you always need to be better than this, and in next iteration, you just need to be better. So this bridging the gap between theory and just to how to connect smart machine learning systems and maybe some optimizers or hyperparameters, or how to evolve the maybe some architecture of the network, that it's just not based on the gradient, but based on some inspiration from real AI or human level AI. So, for example, the Kenneth O. Stanley, he introduced this is a famous researcher. I think that he started in Uber AI, and then he moved to Google and all these interesting research centers. He just in I don't know, 2012, 13, 14, not sure. He just wrote a book and he introduced the novelty search algorithm. And this algorithm was based on some idea that, for example, we have this kind of maze, and here's the global extreme. Here we have some local extreme, this blue dot, but this gradient, is cut by this wall, and all the algorithms are going to gradient, and they will just simply get here. They will not go around, get here. But if you use different metrics, different point of view on these algorithms, you can get to global solution, even though, there is, you are not following only the gradient, which is very interesting. And we can also make some simple and very successful modifications, or we can improve the algorithm with some unconditional approaches. Here list some of them. So we can, as I said, we can be inspired by human AI. We can just improve the popularity and the dynamics, some synergy between the meta-heuristic complex networks, because this is very similar. Because if we have two solutions, and we create another one that is better, this is just like a friend is talking with a friend that gets some better idea. So you can map, or you can model the behavior of the algorithm as a social network, like some Facebook chat. So there are very interesting things that can be done. And we can just look at some non-randomized processes in anti-heuristics and so on. And of course, we can synthesize. So we can have a space of the algorithms, we have a space of symbolic regression, genetic programming, and so on. We can maybe create generalized algorithms, generalized AI by the means of AI. And here we are at this the end of the optimization about this, where EAs meet machine learning, which is basically called neuroevolution. And basically this comes together with some rapid development of successful machine learning, deep learning applications. And this is why, this is the moment when this evolution algorithms winter came slowly to the spring of AI, because there was a re-exploration of evolution algorithms as an effective optimization technique for tasks with a high complexity, the building the architecture of the network, finding the hyperparameters, structure of encoders, and so on, how to synthesize the attention gates in the network, and so on. So we can select optimal features, pre-select some models and architectures and results, whatever. And we can optimize the convolution networks and so on, and feature extractor, and for further processing. We can do many things there, where we just need to find some good combination of the things, skip layers, and so on. And many things that simply we want to synthesize, optimize the structure and the parameters. And that way, basically, the automated machine learning, or auto ML, has been introduced. So this is, let's say, the topic of last 4 or 5 years. Of course, there was many attempts to tune the artificial neural networks parameters by genetic algorithms in 90s and so on. But usually these things were not very explored because of the high dimensionality of the problem and maybe not very good results and high time complexity. But now we have powerful computers, learning technique, learning also is very long, so we can maybe invest some time into the better architecture. So for example, in the very famous research, which is Maulana, he's got a very interesting series of papers about the evolving deep neural networks and this co-deep NEAT or this NEAT technique, you know, this network architecture search. And this is very interesting thing that that is connecting the evolution algorithms, especially the current powerful evolution algorithms with these approaches, with some smart, you know, co-evolution and communication between the populations and organization processes and exploration, exploitation stuff, and just not focusing only on the deep learning, only on the gradient. So they are very interesting. And of course, if you are working with the machine learning and you want to optimize something, there's also another, let's say, alternative approach to Kenneth O. Stanley's novelty algorithm, novelty search, basically where he didn't write exactly how to do that. And maybe you should check the Nevergrad, let's say, research group on Nevergrad, because if you just look at the gradient-free optimization platform, and this gradient-free is used for machine learning for, let's say, it's working, it's used for in machine learning for hyperparameter search. And for example, this research group is very, very tightly connected with Facebook AI. And this is how the networks are being tuned and learned and so on. So this is very good if you can look at this, the Nevergrad technique, which takes some inspiration from evolutionary computation, from these meta-heuristic optimizers. And again, they just get rid of the gradient and just find very interesting, promising results for machine learning. And there are many papers for neuroevolution where the evolution algorithm need machine learning. As I already said, this neural architecture search is neat. It's a nice survey from 2018. We have another, this evolutionary neural auto-ML for deep learning in this Gecko conference in 2019. So we have another, and there are many papers about the auto-ML, NEAT, and co-deep or deep NEAT. The co-deep means co-evolution deep neural network search, architecture search. And this is very interesting for further processing, because if you just maybe follow some blocks of these things that, for example, in almost 2 years ago, so it was the end of July 2019, the Google DeepMind, they just simply said, okay, we just focus on the evolution selection that can be somehow embedded in the training of our networks and the system for example, self-driving cars. So, for example, you can see that this also Google DeepMind is investigating the connection, or let's say this meeting between the AIs and the machine learning, especially very powerful and state-of-the-art AIs, and with this deep learning. Okay, so that's all. I see. Oh, cool! Wow, 50 minutes, a bit late, but I was exactly for 45 minutes performance. So thank you for your attention. I know it was very quick, a lot of information, but if you have maybe later any question, or maybe you can, just do not hesitate to contact me on either my email or the email of my my AI lab, and we can just simply talk later, or we can just simply maybe work on some interesting stuff and so on. Well, so that's all, and now we have maybe some place and time for some quick questions. I'm not sure if we have a time.
Sure, sir. We can definitely take up at least one question, and it was really a very new approach, and your attempt, I believe, has been very successful. Thank you so much for such a nice presentation. And the way you have talked about ECT taxonomy, discussed its advantages and the disadvantages, really I believe, going to show a path to the budding researchers. We are having so many students also from our institute who are researching, and they will be really motivated by your talk. And you have also suggested some very proper statistical tests, including deep statistics tests, and suggested some very important research papers. I believe if they follow them, they will find a true guide. And thank you really so much for such a nice presentation. I think now our chairperson, Professor Polish Dotto, would like to have a few interactions with you.
Okay.
Yeah.
Thank you very much. Thank you.
So, Professor Rohan Sankari, so nice way you have presented your delivered. Really, I love it. So, and I think each and everybody has loved it. And now, as a chairperson, I have a few very light query. You have talked about a list of what algorithms, right? But my point is, when exactly which algorithm is better, how one can identify that? First thing, are you getting my point?
Okay, sorry. Can you ask once more, because I was just some drop of connection.
Okay. A lot of algorithms you have displayed here. You have explained about a lot of algorithms. Now my point is, which algorithm is better to employ in my research, say? So how I can identify that one?
That's a very good question, because as I already said that there's this no freelance theorem. Basically, I cannot guarantee that you apply this algorithm or that algorithm will work better. That's why we always need to perform very good benchmarking and finely tune the algorithms for your problem. But there's one thing that usually, if you look at the winners of the CC competitions, these Gecko competitions, within the frame of last 2-3 years, you always have a good choice if you just tackle the, you always take the winner or the second algorithm of the first algorithm. And what is very good also, that usually on this competition GitHub, you always find the codes of this winning algorithm. So you can just easily run them on a MATLAB or somewhere and get the result. So these winning algorithms are always the good. Maybe they can be sometimes too complex, or just follow how they evolved from which they started this algorithm.
Right. So you talk about hybridization of algorithms techniques, right? In some situation, it may work better. Do you think so?
Yes, in some situations they can. These hybrid algorithms work better, but here. Yeah, but here I have also some really rising, warning finger, especially if you want to publish such hybridized algorithm. Again, there's a problem there, because you have the algorithm like this, which is from this group. You have algorithm from this group, and you have some problem. And this intersection is so small that the reviewers will usually say, "Okay, who cares about the problem?" so again, you have to be very, very careful. How to maybe publish your work, and it must be done in the way that it's useful for maybe broader cases and not like this. But of course, this hybrid algorithm is an option for the better performance. If for example the standard algorithm doesn't work, another algorithm doesn't work, or you don't get the good results, maybe you can try to put some things and ideas together and you get something. But don't call it a new algorithm. Just simply say, okay, I am using some these and these, and I get some interesting results that can be scaled, to some different scenarios and different problems, of course. Yeah.
So thank you very much.
Polish Dotto,
Yeah.
I have one question to Professor Sankari.
Sure, please.
So
Yes.
my chemical student wants to know, how can we apply meta heuristic algorithm for dynamic situation, especially in chemical industry? I repeat question again.
Okay.
How can we apply meta heuristic algorithm for dynamic situation, especially for chemical industry? because larger
Okay.
number of participants from chemical industry.
Yes, the thing is that, for example, my PhD thesis, or I think master thesis was about the optimization of batch reactor. So I was working with some technology, some chemical industry for my master thesis. So it is possible, but of course, that because you can use it as an optimizer, you can if you have some criterion for optimal control of some reactor or some technology process, you can define some cost function for the energy scenarios, time scenarios. Again, you can use the evolution algorithms for this is very dangerous sometimes, because you can use it for optimizing of the process itself. But then again, there's these big problems, because I cannot give you the guarantee of the quality of solution and of the convergence. And you cannot make the reverse engineering. It's the same as with the neural networks. You can teach the neural networks to maybe operate the chemical industry, but if something happened, you have absolutely no idea why it happened, because there's no river, there's no let's say reverse, there's no backstepping in the network. So again, the algorithms are very widely used in technology. In chemical industry, can be maybe it should be more and more tested and proved, but it can be used in some optimal control. So you can tune some PID controller. You can use some control feedbacks based on some inputs. Maybe you can design some chemical say technology parts. For example, in my thesis, I was designing the reactor, or these diameters, height, and flow in, flow out, cooling scheme, and the thickness of the walls. This can be also very easily applied if you have some mathematical model of how it works. So you can just try to find some new design of the process. And especially in chemical industry and maybe some technology, the evolution algorithms can be used for scheduling and planning. To find a perfect schedule, when to do what to do, when to do this process, maybe to make some small gaps, because if you use some chemical substances that are very close to another chemical substances, that maybe the time between the switch to processes can be shorter, and so on. So you can use it in planning, scheduling of tasks, and so on. Many ways. But as I said, please do not hesitate to contact me, and we can just look at that.
Okay, many thanks.
You're welcome.
Okay.
Thank you.
Over to Priyanka ma'am.
Thank you so much, sir. And it was really a very interesting discussion going on here. But as there is a time constraint and we must go on. And thank you once again, Dr. Senari, for providing us.
Dr. Senari, I want to add one line. You are not only a good researcher, you are a good teacher also, because the way of teaching is amazing. So
exactly.
Thank you very much. Thank
and
you.
The way
your pronunciation and way of teaching is excellent. We are just amazing. Means we are enjoying your lecture. All the students are saying here they are enjoying your lectures. So I hope one
good.
So
once again, thank you.
Yeah,
very
thanks
much
a lot for being with us here. And as you have given us the permission, definitely our students will be sending, if they're having some such questions, to you through email, and hope you would be guiding them in this way only. Thank you so much.
Of course.
And and now we would like to move on to our next speaker, who is already here with us. Our next speaker is Professor Tanmoy Shom from IIT BHU, that is Benares Hindu University, a very old and highly reputed Indian Institute of Technology. Professor Som is a renowned professor in the Department of Mathematics and is a fervent researcher in this field, having keen research interest and expertise in functional analysis, fuzzy set theory, optimization modeling, computing, image processing. Some of his research works include tolerance-based intuitionistic fuzzy rough set approach for attribute reduction, an automated vehicle license plate recognition system, some fixed input theorems for fuzzy mappings, or the theory of soft sets, soft relation, and fuzzy soft relation, handwritten character recognition using multi-resolution technique, and Euclidean distance metric, etc., etc., etc. And today, this renowned professor is going to speak on decision-making problems. Now, sir, please deliver your talk and enrich us.
Hello.
Yes, sir.
Are you getting my voice?
Yes, sir. Yes, sir. You're absolutely audible.
So, very good evening to you all. So, I think many of you are waiting for the next lecture, okay? And that is based on some fuzzy set concepts, okay? And first of all, I thank Dr. DK. Jan, for inviting me for delivering a talk. And I have just chosen one topic. Maybe it will be useful or linked to your program. Okay. So let me share my slides. Certainly the good program last 4 days, and it is the last day. You are going to have.
Tomorrow is the last day, sir. Tomorrow.
Tomorrow.
Yeah.
I was thinking that I am having my lecture on the last day, but anyway, it is good. One day before. Let me see my slide. Just wait. So, are you getting the slide?
Yes, make
yes,
it
sir.
large.
Yes, sir.
Visible?
Yes,
Yeah.
sir. It's visible. Just
So,
if you kindly share the full screen.
It is in full screen.
Okay.
Please check.
But sir, we are seeing a. If you kindly go to the slideshow.
Okay, just wait. Then let me. Slideshow. Okay.
Last bottom. Last one.
This
Below.
one?
No,
sir,
below,
this
below.
one. Sir, this one. Slideshow.
I'm just checking where it is.
Sir, after animations, at the top, home, insert, design, transitions, animations, and then slideshow. Not new slides, sir. Sir, at the top.
This is slides, but.
Sir, brown colored taskbar.
Acha. It is nothing like that. I'm not getting such type of thing here.
Okay, sir. As we are seeing here, on the taskbar, sir, brown. On your taskbar of the screen.
Am I in the screen or?
Yes, sir. We can see you, and the screen is also visible.
Okay,
But
slide is visible or not?
Yes, sir.
Slide is visible, but smaller size.
Yes,
Okay.
sir. Not full screen.
But there is a cup. If I
This side. Okay, make it.
using that cup, if I am doing, this is the last size. I think it will be all right. Okay.
Okay, sir. Fine, sir. Carry on.
So my topic is tolerance-based intuitionistic fuzzy rough set approach for feature selection. That feature selection or the attribute reduction is a challenging task in data mining, okay, or getting some useful decision out of a given data. And we are giving some tolerance here. Okay, every day in our day-to-day life, you have some limit of everything. You cannot go beyond that. So we are doing something that I can tolerate up to this, After that, I won't be able to tolerate, and therefore, this is something, a new concept here. So what is the main problem? The main problem is to handle a big data. Every day or every moment, huge millions of data is generated. And then to handle such type of data is a difficult task. Humanly, it is impossible. Only using machines, we are able to do it. And with the machines, also we have to give proper technique. Otherwise, machine will also fail. Machine will also fail, and it will not give you the required result what you require. So size of data is a very challenging task nowadays, okay, to handle any size of data. And then, therefore, we require the size of data means it may be of very high dimension. So unless we reduce the dimension of the data, it will be difficult to handle. So the first task will be to reduce the data size. That is called dimensionality reduction. Okay, and that dimensionality reduction is done by choosing the proper features for for recognizing the data, what is available, what is there in the data. Okay, the correct features. Okay, that is the main thing. So, well, this is one task. Then, if your data is heterogeneous, then it will be certainly another difficult task. Okay, if it is balanced, all right, you can handle it. But if it is not balanced, that is imbalanced data, then again it is a problem. We have to use another technique. So whatever technique I am going to handle here, that is a balanced data. So that is called class imbalance. There may be in one class is with very low quantity, and the other class is in very huge. The size of data of one class is very huge, another class is very small, and therefore, in that case, again, this method or the whatever methods available may not be able to classify in a better way, and therefore we have to take care of everything. And then coming to our technique. So there are many techniques available. One is fuzzy set theory technique developed by Professor Azad, okay, 1965, and then he developed this theory, and this theory is also applicable to handle some data. Okay, not all, because it has also limitations. Fuzzy set theory also has limitations. We'll tell you a little later. Then we have what is called rough set theory, that is developed by Pollock in 1984 or something, 1980s. And then that theory is also quite good enough to handle data recognition. Okay. So, but what is happening? The day they have developed the method, that time the data size was quite small, and the method developed were applicable, very well applicable. They were able to do and recognize and get the useful decision. But as the data size has increased enormously, it was difficult to use the same technique, and therefore we require every day some new technique, or we have to modify our already known techniques. And therefore, we come across some intuitionistic fuzzy set theory technique. Okay, in fuzzy set theory, we have membership. But what we have extra in intuitionistic fuzzy set, we have membership and non-membership of the same. Suppose I say something belongs to a, okay, say how tall a person is in a society. Okay, let us take a society, and if I am taking just one example of a particular person, how tall he is. Okay, it is a fuzzy concept. And okay, somebody say he is 6 feet, somebody will say, but I have some membership. 6 feet, I have some membership. But how much he is not tall at the same time. Okay, so that concept is there as intuitionistic fuzzy set theory. Then we have combined, that is, we have something what is called fuzzy rough set theory, then intuitionistic fuzzy rough set theory. So all these theories are going to help us in dealing with large data where we have much complexity. The data, the nature of the data is not very simple, and we have to use some new technique. So the methodologies now, what are the useful applications? What are the techniques available with us? We have, sorry. So that is, first application is that extractions of important information out of the given data set.
Sir, excuse me,
Yeah,
sir, the
please.
slides are not changing.
Hmm?
So the slides are not changing. We're still on the first slide.
Is it?
Yes.
Let me again share the slide. Sorry, I think there is something. Probably I have. Just wait. You could have told me in the beginning itself. Anyway, let me
Sir,
again.
actually, it was not coming, so we felt that it will be changed.
Because I saw the biggest side in my screen once. Is it?
Sir, it's coming
Yeah, smaller
in
side.
that
Let
way
me
only.
make
Yes.
it bigger.
But sir, unless and until you go for slideshow, again it will stick to the first one, or else it will have to be done manually.
Now, is it moving?
No.
No.
No,
Then
sir.
what? Just wait. How come it is not?
Yes, sir. Now it has come to the introduction.
Okay. Let me see.
Sir, every time you'll have to click, sir, otherwise it will not come.
No.
Automatically it is not coming. Yes, sir.
Is it all right? It is coming, I think.
Yes, sir. Now it is coming as you are scrolling down.
But the size may be smaller here.
Sir, it's fine, sir. It is
Okay.
visible.
Okay. So
This
what
is
I
now
have.
slide number 2.
Yeah,
Issues to
slide
handle
number
big set
2.
data. Yeah.
So just I discussed all these issues to handle with
Yes,
big
sir. You have
data
already.
is the size of the data, dimensionality reduction, heterogeneity of the data, class imbalance, and then the techniques are nothing but fuzzy set theory technique, rough set
Yes,
theory
yes.
technique, intuitionistic fuzzy set theory technique, or intuitionistic fuzzy rough set theory technique. These are all available in literature. Okay. So what are the applications of this? First one is the extraction of important information out of the given data set. Then remember that doing this, we require machine learning. I am getting one more voice. Somebody is, let us mute the others. Okay. Speak, other system. So next is that, so we require machine learning since we are going to use machines. Humanly, it is not possible, and therefore we need to train the machine, and then that machine will do the classification. Okay, so these are the way we are going to do. So machine learning is a part of this work. Okay, then get decision in respect of either the given data, and if I add some new data, I will also again get, okay, that is extrapolation in mathematics. Okay, we will get the what is there in the new data even. Okay, then technologically designing machines to handle huge number of objects and classify them in different classes. Okay, so we are technologically designing, say, machines. We are going to have some better machines, okay, equipped with some new, what is called programs, or new, what is, okay, softwares. We can design some new softwares and get the problem solved. So these are the things associated with the problem which I am discussing. Okay. So what is there? Attribute reduction or feature selection. This is an interesting area of research in machine learning or pattern recognition or data mining or even in statistics or bioinformatics. Okay, all these. Due to generation of huge amount of real valued data, generally the data we take in real value, okay. Some dimensionality reduction is required. Techniques are required in order to get a smaller. If the size is huge, it will not be possible to handle, and therefore we require some dimensionality reduction to get a smaller set of informative features. That what are the features which is responsible for getting the decision to improve the performance. Okay, this will speed up the performance of the machine. Okay, improve the performance of the machine, and then storage also. This will also reduce the storage space, and that will also increase the accuracy of the algorithm or the method or the process. Feature selection is one of the dimensionality reduction techniques which preserves the salient characteristic of the information. That is more important. Okay. If we lose, even in dimensionality reduction, if we lose some of the salient information, then there is the purpose is not solved. Then it reduces highly correlated data. If there are huge number of highly correlated data, then that can be removed. Okay, unnecessary, it will create problem. Okay, which otherwise may lead to lower accuracy. Accuracy may reduce. Similarly, feature selection techniques focus on more relevant, okay, the relevant and less redundant data. Okay, whichever relevant information or relevant features which is responsible for a decision. Okay, and any feature which is not redundant, okay, or is redundancy is less, that is important here in our concept. So its applications are found in many areas like web classification, text category. Just like what you do, suppose you are getting a mail, whether this mail will go to your primary mail or web mail, this is already there. Okay, it is not automatically coming. There is a process there. The same machine learning process is installed there, and that is working like exactly this kind of problem what we are doing. Sometimes you see that your main mail has gone to the spam, and you are searching in your main mail. It is sometimes there is error. Okay, so if the data is huge, this type of problem may come, and it happens very often. So one technique is fuzzy set theory technique. Then we have rough set theory technique developed by Pollock. Based approach is one of the most important techniques of feature selection. That is another technique. Okay, and that acquires information from the data set itself. But what are the difficulties? Rough set theory does not need any external information. Okay, for the feature selection, it handles the vagueness associated with the data, with the information, and this method can be applied to only discrete data. So if I have a data in real, I have to discretize it, and then apply the rough set theory technique. So this is the difficulty, and in that case, we will lose some information while discretizing, and therefore we may not be able to get very good results. Okay. So therefore, discretization methods are applied in order to tackle the real valued data system before feature selection, and this usually may lead to information loss. In order to cope up with this problem, what is there? Solution is that fuzzy rough set theory technique approach. Okay, that was developed by DeVos and Pratt by combining fuzzy set and rough set. Okay, to handle both uncertainty and vagueness. Okay, there are different types of uncertainties available in the data. Okay, since the data is complex, and there are vagueness also at the same time. Okay, so in order to tackle more uncertain and complex information system, many concepts have been presented. So one of them is intuitionistic fuzzy set based method that was developed by Atmaso. Okay, And it is one of them in which membership, non-membership, and hesitancy functions are considered simultaneously. The intuitionistic fuzzy set is an extension of course, Jad's fuzzy set, and Jad's fuzzy set. And it is much more stronger. It has much more stronger ability to deal with such in any information system, and we can draw a better decision out of that, and that is called, it is going to handle the fragile ambiguities, what is called fragile ambiguities. Okay. And then, however, very few research work have been introduced in the area of feature selection based on intuitionistic fuzzy. I'm adding here rough set also. We have techniques using intuitionistic fuzzy set, but now we are going to use intuitionistic fuzzy rough set. So hereby we propose a new type of approach known as intuitionistic fuzzy rough set approach. That is, we have some upper approximation, some lower approximation. Based on that, we are going to have some feature selection, but with some tolerance. This is an additional factor. We tolerate up to something, and then we get a decision. So what is now rough set? I think I have written somewhere else. So this is suppose U is the universal set, and then this universal set is partitioned into square blocks, and my set in consideration is capital X, that is enclosed in this. Okay, suppose my consider is this X set, and how many blocks are inside this? That is called the lower approximation. Okay, and then I have just if I add some more boxes just adjacent to all this lower approximation, I will get another set of boxes which contains the elements of X and some elements outside X. That is called, the intersection is non-empty, and this is called the upper approximation of X. The set X, which is given by this curve, closed curve. So I have some elements which are completely inside, and with this square blocks, it is the lower approximation, and those are which are in the boundary and with these boxes, okay, outside the curve, and that is the upper approximation. So in this approach, we are having some threshold, and then I'm coming. So what are some definitions? I think some of the definitions you already know. The fuzzy set, mathematically, it is nothing but it is actually giving you a membership to every element of the universe with respect to some, say, length, breadth, or some taste, or some feature, maybe what is the color, what is the petal size, or something, depending on the data, whatever you are handling, or the data of, say, hospital data, say a disease, and then with respect to that, what are the symptoms? With respect to symptoms, we have some membership. Okay, so that is nothing but it is from capital X to 0, 1. Capital X is the set of my elements, the members, objects, and then I have, for each object, I have a membership in 0, 1. Okay, so mu AX is the membership, and then these are some fuzzy values. If I take intuitionistic fuzzy, that is membership, if I write L, and non-membership by N, so then L plus M is always less than equal to M. Okay, and that lies between 0 and 1. Okay, that is called intuitionistic fuzzy value. I represent L is membership, M is the non-membership. The sum is less than equal to 1. The value is always greater than equal to 0. And then what is that intuitionistic fuzzy set theoretic approach? U be the universe of discourse of objects, and intuitionistic fuzzy set B in the universe U is the collection of objects having, okay, I have the element X, its membership value, its non-membership value, okay, with respect to each X. And LB is the membership, MB is the non-membership degree of. And I have one more thing, 1 minus the sum of membership and non-membership. That is called the hesitancy relation, okay? And this also plays an important role in this theory, okay? Any fuzzy set B with only membership can be recognized as a intuitionistic fuzzy. Sorry, it is nothing but it is a, so any fuzzy set is a special case of intuitionistic fuzzy set where we do not have non-membership, okay? So that is a special case. Now, to handle such big data, what we require, okay, what we define here, something what is called fuzzy decision system, intuitionistic fuzzy decision system. Now remember that whatever decisions are available to us, these are based on some features, okay? So I have, we write a quadruple U, B, V, F, and F, where U is the collection of objects called the universe of discourse. B is the non-empty collection of finite attributes, okay? Out of these finite attributes, we have conditional attributes as well as decision attributes, okay? And VF is the collection of fuzzy values, okay? And F is the information function defined as, F is a function from U cross B to VF, okay? So it is taking an object and taking its what is called attribute and then coming to VB. VB is nothing but VF, the collection of fuzzy values. So what is its value? Corresponding membership value, okay, like this. So, and this B is union of C and D, conditional attribute, decision attribute, and with the condition that C intersection D is empty, okay? So nothing is common between C and D. For example, let us take, okay, a simple example I have a set of objects 1, 2, 3, 4, 5, 6. Okay, maybe x1, x2, x3, x4, x5, x6. And I have attributes in the data, that is A, B, C, D. And here A, B, C are responsible for a decision D. Okay, D is the decision. Okay, and suppose I have object 1 whose what is called attribute A is the fuzzy value, that's membership. Attribute A membership 0.2, attribute B 0.4, attribute C 0. It is in decision system N. Okay. Similarly, I have for all the objects, I have these are the values and these are my decision system. Okay. And what I have here, I have just taken for simple understanding 2 classes. One is N class, okay, another is Y. So I have element 1 in N, element 1, 3, and 6 are in the class N, and the remaining are in the class Y, okay. So this is the thing, and with this we will take care little later also while doing with, this is just with fuzzy concept. Now if I take another one, what is there? Intuitionistic fuzzy. In the previous one, I have only membership. Now, okay, suppose I say color, or suppose in case of medical decision, say a symptom is there. How much that symptom, how much pain he is having, or how much, okay, say coughing, all this, how much pain is there, how much patient is not able to say very clearly this much pain or that much pain, okay. So I have membership as well as not membership. Okay. Similarly, say color. If I say light blue, so then how much light blue or how much not light blue? Very difficult. It is very difficult to distinct. And therefore, I have membership. So that is LBX and MBX is the non-membership. So this is my intuitionistic fuzzy system. Okay. My broad structure is same, UB, VF, IF, now this is intuitionistic for me, and this a mapping which is taking U cross B to now intuitionistic fuzzy system. So I have a membership as well as non-membership. And then I have the features. Out of all the features, some features are conditional features and others are decisions. So based on those conditions, I have a decision. Okay. Just like if a patient is having fever, headache, and blah, 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 then I get maybe it is typhoid, maybe it is viral. So that depends, okay, on what are the quantum of those symptoms. Okay. So what are the quantum of those features? I get the decision. So there are conditional attributes and decision attributes. So just the previous example I'm explaining with respect to intuitionistic fuzzy. So for each object, 1, 2, 3, 4, 5, 6, say attribute A, B, C, how much it is a member, say 0.16 is the membership, 0.64 is the non-membership, okay? And this is done by some expert. It is not that we are deciding all this. This is done by some expert. Similarly, feature B, membership is 0.32, non-membership 0.48. And remember that not always this sum is 1. It is sometimes less, okay? It cannot be more than 1. And it is sum is always greater than 0. Similarly, I have, for C, I have membership, non-membership. Sorry, object 1, I have membership, non-membership for feature C, and then it is in decision class N. So for all these elements, this is in the standard data we have taken, and it is done by other authors also earlier. Now, next. So here we have not introduced any rough approach here, but if we are going to use that rough approach, we are having equivalence classes. In rough set, you have blocks. So some blocks are equivalent to other blocks. So what is that? How to know? So what is this rough set approach? So we write it in different way. So this we write as intuitionistic fuzzy. Okay, this is an information system where the X is the class of objects and the what is called attributes, C union D. C is the conditional attribute, D is the decision attribute. Okay, so this is my information system, that I have objects and some decisions. Okay, and then, so objects means it is in the universe of discourse. C and D are the finite conditional attributes, not infinite. I have finite conditional attributes and finite decision attributes. And then I have some mapping from X to FA, that is the set of values that attribute A may take. For a object A, I have some value. Okay. For the feature A, I have some membership, some non-membership. Okay. And then it is coming to that an object A, how much it belongs to. Certainly, object A refers some conditional attributes and some decision attribute. So I have a system like this. And then how we know that two different objects are similar or not, because we are going to introduce here similarity complex. So we write that two elements x1, x2 are in one class if their, say, membership value are same. Membership value in that class is same. Okay. So I can partition the whole X into different classes. One class having one particular, say, attribute values like this. So another class, another attribute values like this. Okay. And therefore, we are able to partition the whole of X. Okay. So these are mathematical notations. Okay. Once I have different equivalence relation, and then that will generate equivalence classes immediately. So what I have is system, and then we say that a particular pair is in the same class. Okay, this equivalence class, and then we say that if x1, x2 are in the same class, then we say that the elements x1, x2, the objects x1, x2 are indiscernible. Okay, indiscernible. And then what we have, some upper and lower approximation in rough set approach. So what is that? And if remember all these different classes are what is called non-intersecting. Okay, and then what we have, some, but out of this lower and upper approximation, I have some non-empty intersection. Okay, now here as we have explained in the figure, I have what is called how to write. This is called lower approximation. It is lower approximation is set of all objects such that this equivalence class certainly fully contained in U, and I have upper approximation of the element X such that the equivalence class, if I intersect with U, I have non-empty set. Okay, so that is explained through my this figure. Yeah, you just see here. I have some equivalence classes here, some equivalence classes there. So it is quite easy to understand. Okay, that this equivalence class and another equivalence class, they are different. Okay, maybe with respect to some feature. Okay, or different features, I get say one box, this another box like this. And then if there is something, okay, something is outside and that is in the boundary, it is taking some element of X. Okay, so I have all these concepts here. Now after this, this is the rough set approach here, what we have. Yeah, so out of this I have what is called lower approximation and upper approximation, and this lower approximation is going to take part in my decision. Okay, upper approximation is in the boundary, and therefore it is not going to take part in the hard decision. Okay, and then I have some what is called positive region. So once the elements, the objects are inside, so I have some positive region, that is all union of all these boxes inside the whole outer circle. Okay, so this box union is nothing but the lower approximation. Okay, then I have positive region, and those positive region are going to give you what is the degree of dependency. Say this positive region contains, okay, the features, important features, and those important features are going to give you some decision. And for that, I have some degree of dependency. The decision depends on what is called degree of dependency. Okay, and that degree of dependency is formulated or given by what is the size possibility, one region, okay, POSQR. Okay, so how much a particular element is the, sorry, what is Q here? Just wait, degree of dependency of R on Q. Okay, let me, okay, I have the whole class. If I take a subset R, one equivalence, I have some degree of dependency. One is, sorry, conditional attribute and decision attribute. So R is a decision attribute here, Q is a conditional attribute. So this decision, the decision R, depending on how much it depends on Q, okay, this is given by this positive region, this value. Okay, so a reduct B is defined as a subset of C, and okay, and that is given by, suppose this value, the decision of, okay, the attribute value D is same as attribute value of C. Okay, these two values are same. We'll come to example, then it will be more clear. Okay, such that the positive region, you see, positive region with respect to conditional attribute B and conditional attribute C, they are same. Okay, so then we get a reduct. Out of that, we get a reduct. Now, that was the method what is called rough set approach. Now, if I use some tolerance, I cannot tolerate some value. Okay, beyond that I cannot accept, and therefore I have to use something similarity. Of course, similarity relation is there, but something tolerance that similarity is not below delta, not below delta. I must have some similarity level. It is not that, say, 0.001 similarity. No, we cannot accept. Or 0.01 or 0.5. So what I have here, this is what is called similarity between A and B with respect to attribute A. Okay, and that is given by this. Okay, what is the attribute value of with respect to object x1? What is the attribute value? Okay, with respect to x2, and then what is the maximum value of A max, A min? Okay, and then this is my similarity 1 minus this, and if this is greater than delta, this is my tolerance. This is my threshold. Sometimes we say threshold. Based on this, we are going to have my decision system. So with this system, we are going to have lower approximation and upper approximation. The rough set approach, same approach is being implemented here. I have lower approximation, upper approximation. So this is a tolerance rough set. Because I have introduced a tolerance, and therefore, whatever I am getting, this is called tolerance rough set. And then I have positive region corresponding and corresponding degree of dependency. The same thing, but now with respect to some tolerance delta. I have some tolerance delta. I have all the classes, lower approximation classes, that is my positive region, and degree of dependency given by this. Okay, that is the positive region of R with respect to Q and delta. Okay, with respect to attribute Q and tolerance delta and the wholly. And this is the thing we are going to implement this. Okay, tolerance based rough set. Now here I have not you. Okay, we have used the same thing is I think, yeah, this is the same approach. I will come to the example. It is written in another form. Okay, the same thing is being written in another form, similarity relation, the same thing. So I have some, what is the similarity class? Okay, if x, y are in the same similarity class, if their values are same, okay, their values are same, and then I have some up. Now you see delta lower is lower approximation, delta upper is the upper approximation. Okay, how we define upper approximation and lower approximation? And then this delta is nothing but your with respect to that tolerance delta. And then we have the positive region and the what is called degree of dependency of a particular feature, okay, of the main decision feature with respect to the conditional features. So this we are going to implement. And then if we use something more here, we have not used intuitionistic. That was only fuzzy rough. But if I use intuitionistic, I have membership as well as non-membership. And therefore, my similarity relation definition is modified. And this is given by this. Okay, similarity of two objects, x1, x2, is given by this relation, that is 1 minus. This alpha, beta, gamma are some weight factors here. And then the distance of x1 with respect to mu a. Okay, x1, x2, xi or xj distance. Then with respect to beta, what is, okay, the same. Membership, non-membership, and hesitancy. All those distance squares, and this with alpha, beta, gamma, and alpha, beta, gamma satisfying the properties. So you see this mu a is membership, nu is non-membership, pi is hesitancy. And then what is that important condition? Alpha, beta plus gamma is equal to 1. And all these, that alpha is larger than beta, beta is strictly larger than gamma. And all these are less than equal to 1 and greater than equal to 0. And then if this similarity value is greater than delta, this is my tolerance. Okay. just like the tolerance. Say, suppose your headache is little more. Okay, if you do not have a particular quantity of headache, you will not go to the doctor. Okay, just like that, if you do not have high fever, you do not going to go to consult doctor. Like that, I have a tolerance here. So for everything we require some tolerance, then the decision will be much better. Decision will be much better. So I have, with respect to this, lower approximation and upper approximation. Now this mathematically we write it like this, because I have membership, non-membership, intuitionistic. So this is my class, and then this is my positive region with this with all lower approximation, and then this is my what is called degree of dependency, because some of the factors depend on the others. So, and therefore this is my degree of dependency of the decision attribute on conditional attributes in the environment of intuitionistic fuzzy. Okay, rough set. So this is the actual program which will be able to solve the problem. Once a given data is there, mathematically, suppose a huge data is there, manually it is not possible to calculate all these values, and therefore we require a program. So all these are some mathematical approaches being used. This is the Pollux rough set approach. So all these are there. I don't want to go in detail because this is much more mathematical. The same concept is being what is called extended in this. These are the things which are being used. Okay. So these are some mathematical, easily we can draw this conclusion. There are nothing difficult. Yeah. Now let me come to the example. This is more important. Okay. So first we will use what is called only fuzzy set, then intuitionistic fuzzy set, and then rough set. Okay. So I have exactly that classical example what I started with. I have 6 objects and 4 attributes. Out of this, 3 are conditional, A, B, C are conditional, and D is decision. And what I know that I have element attribute A that I write as capital A, attribute B we write capital B, attribute C we write capital C, and delta is my delta is my what is called threshold value. Yeah. How much time is there, please? I think another 5 to 10 minutes. I will go and finish it.
Yeah, you can take that.
Yeah. So here I have, now you see in class 1, I have 2 classes here, N, N, and N, and then Y, Y. These are my decision classes. And with respect to this delta 0.7, what I am getting, the object 1, 2 are in a similar class, one similar. Similarly, 3, 4 in another similar class, and 5, 6 is another similar class. Okay, the calculation is done in another, actually that calculation part is not shown here. Then with respect to, you see, okay, A, with respect to object A, this is the decision class. Then with respect to capital B means feature B, capital A means feature A class. With respect to feature class B, and delta is my threshold. Then I have only 2 classes, 1, 2, 3, 4, 5, and in one class, and 6 is in another class. Then if I change, if I start with, this is my initial starting, and if I take C is my object, then what are the similarity classes? These are nothing but similarity classes. 1, then 2, 3, 4, 5, 2, 4, 5, 6 in one class, and 3 is in another class. Okay. So these are with respect to attribute B and attribute A, B, C, and the threshold 2.7. Sorry. And then, so if I take, if I go, why this is 136 and 245. You just see here, my class, my decision class contains 136 is one class, and another is 245 is another class. So with respect to this decision class, what is happening? Okay, whether whatever is evaluated, they are completely belonging to this. You see, this is my whatever I am getting using fuzzy set approach. None of them are contained in 136 totally. So that is 5. Similarly, none of them are contained totally in 245. So it is 5. So if I take, this is A delta, okay, if this is with respect to feature A, and then what I get, if I take union of all this is 5, and therefore degree of dependency is nothing but 0, because this is the size. What is that size? Size is nothing but 0. Similarly, the size of X is nothing but 6, okay? And then if I calculate, similarly, if I start with B, I get 1 by 6. If I start with C, that is my feature C and feature B, I get 1 by 6, 2 by 6. And remember, what is the highest here? Dependency. Highest is nothing but 2 by 6. And therefore, my decision depends more on the attribute C. And therefore, C is my reduct. Okay. I have 3 values. Out of this, the maximum one we choose. And that is my first attribute selected. Okay, that is my first reduction. Similarly, now in this, I add one more attribute. I start with single attribute and calculate this. If this is going to give you a result, we take that one, then add one more attribute and again calculate. What are the similarity class? Okay, AC. Then similarity class, I get 1, 2, 3, 4, and 5, 6 together. Then if I take B and C, okay, then I have, these are the similarity classes. Corresponding degree of dependencies are, if I calculate, one is 4 by 6. That is, dependency on attribute A and C is 4 by 6. And dependency on B and C together is 3 by 6. The largest is 4 by 6. And therefore, my next attribute will be, next feature selection will be AC. Okay, the largest one. And remember that these values cannot increase more than 1. Now, in A and C, I increase the last attribute and again calculate. Okay, step by step we go. Okay, I start with one attribute, calculate all these values and get a decision. Then I add the next attribute. If that particular degree of dependency does not increase, then it will give you that the other class is the highest class. So this, since again here it has increased, now if I take all the 3 attributes, step by step moving, I get here, these are the classes 1, 2, 3, 4, 5, all separate singletons. And this degree of dependency now becomes 6 by 6, that is 1, that is the largest. And therefore, the final reduct is ABC. All ABC are the reduct here in this case. Okay. Now, this is using fuzzy set approach. But now if I apply intuitionistic fuzzy approach, I have, this is my data. And then if I calculate, we have the similarity relation. And I start with, okay, A is my attribute A, capital B is the attribute B, capital C is the attribute C. Again, delta is same, 0.7. Then similarity class with respect to attribute A and with tolerance delta. These are the 2 classes I get. If I start with feature B and then the tolerance class, these are the 2 classes, equivalence classes, similarity classes. Okay. And then if I start with object C, then I have these 3 similarity classes. And then what are the lower approximation? I get in both the cases 5, and therefore initially what I get, the positive region is 5, and therefore this value is nothing but, if I calculate degree of dependency, With respect to A delta, I get 0 by 6. With respect to B delta, 1 by 6. With respect to C delta, C means feature C, and then 2 by 6. The highest is 2 by 6, and therefore attribute C is the reduct. Okay, initially C is the reduct. Now I add with C other two attributes and recalculate. Okay, so in C, what I can add? A and B separately, one by one. So if I add A, new similarity class is this: 1, 2, 4, 3, and 5, 6. If I add B, my new similarity class is 1, 2, 3, 5, and 3 and 6. These are my objects which are in this similarity class. And then if I calculate the degree of dependency, of this decision on AC is 4 by 6. Similarly, degree of dependency of Q with respect to the feature B and C, this is sigma, that is 1. 1 is the largest, so this will be taken, okay, the largest one. And this is the degree of, and therefore the reduct is nothing but B and C. And we have to stop here because we have reached the maximum value. The degree of dependency cannot be more than 1. And once we have reached 1, that means this is my final decision. We need not apply one more attribute to be added there. Okay, this is the final decision. So what I just see that in the previous case, when we applied only fuzzy, we get A, B, C, all the elements were making decision, okay, responsible for getting the decision. But if I apply intuitionistic fuzzy, what I am getting, only attribute B and C are responsible for the same decision. And therefore, you just see that we are getting a better, it is less, it is going to give you a simpler solution in that respect. So I have the same conclusion that we have presented two methods dealing with real, now this is a real valued data in getting the feature selection or attribute reduction by the use of, I have used tolerance. Okay, if I take different tolerant, I may have different decision. Okay, fuzzy rough set approach. It is found that the latter approach consisted in smaller subsets, maintaining a high level of performance. The performance level is high. So we can have future work maybe there include the extension of tolerance base for type 2. This we have taken only type 1 fuzzy rough set. Okay. And therefore, if we go for type 2 fuzzy set, we may have some more complexity and we may get, okay, whatever solutions, whatever methods are available, we may have some better method. So these are the things, and then some references I have, which are generally used. And this is done with two of my students, S. Srivastav and Shivani Singh. Okay, so this is all today. Thank you very much. If there are some questions, please.
Thank you so much, sir. It was a very elaborate explanation from an expert professor of mathematics doing true research in the field. So nicely showing various data sets. You're explaining intuitionistic fuzzy, the rough set fuzzy, the similarity class in them, and how one has an edge over the other in several situations. It was really a marvelous class, and we are ending our session today with this, but it was really very, very interesting and very, very, illuminating. And now I believe our chairperson would like to say a few words. I think he's already ready with a few questions.
Yeah, please.
Yeah.
Questions.
Thank you.
Yes,
So,
follow,
sir,
sir.
yeah, you have presented so smoothly and nicely.
Sometimes I have become fast. Maybe
It
cover
was
up
needed.
the time constraint.
Exactly.
Is it audible?
Yes, I'm good. Please continue.
Okay. Is it audible? Audible, sir? Is it audible?
Yes.
Yes,
Am
sir,
I
it's
audible, sir?
audible. It's audible. It's audible.
Yes.
Am I audible, sir? Okay, thank you.
Yes, sir, you're absolutely audible.
One thing we know, when when phi set theory is applicable in situation when we have small sample size, right? But you talk about the big data. Then what is the importance of using fuzzy? Where when we have a big data set, then we can definitely use our classical set theory. Is not it, sir?
Now, classical set theory will not work because we are in what is called with some complex nature. The set is not very simple thing here. Okay, it has different features, and all those features are not very clear. And that is why we are using either fuzziness or intuitionistic fuzziness. Okay. Fuzziness will give you certain decision. Intuitionistic fuzzy will give you much better decision. And if I employ a rough set there, again, it may give a better result. May or may not. Nothing we can say because that is everything is uncertain here.
So, sir, again, some extensions are going on. Intuitionistic you have presented here. After that, you can say Pythagorean is there, then Fermatian is there, and finally Qurang. It means extension gives us what? Give us freedom or independence to collect or assign data in an independent way, right, sir? Are you getting my point?
No, it is dependency
what do you
on
think?
the features.
Yeah, on the features.
Yeah.
Meaning extension gives us freedom, right? Extension gives us freedom to assign membership or non-membership values, right, sir?
Yes. No, it is not that freedom. It is the expert decision to get the membership, non-membership. You cannot, you do not have the freedom to choose your membership or non-membership. It is the expert. Suppose how much headache you have, the doctor can say by some test. Okay, it is not that my headache is 0.5 and another my not headache is 0.2. We cannot say. It is the some expert will say.
Okay. Nice. In somewhere you told that about similarity measure, similarity degree, right, sir? And in similarity degree, you told about threshold value. The question is who will fix or define the threshold value exactly?
Pardon?
That will be expert or something? Who will fix?
You see, once the data is there, everything is available, and therefore mathematically we can calculate.
No, that is fine. Who will fix? Who will fix the threshold value?
Tolerance value.
Fix the threshold value? No, fix. Threshold value. Who will fix the threshold value?
Threshold value.
Delta value.
That is up to you. Who are dealing with the data? Suppose you are handling that data. Say. So I can take decision maker will be the system, or maybe the organization will fix my threshold value. So say your college will have one threshold, another college will have another threshold. Okay, nobody else.
Right. Okay, thank you, sir.
Okay. We were having a really very enlightening talk, and in every session we had several questions, and our chairperson has really been very, very interactive today because the sessions were really very, very enlightening. And thanks to Tanmay sir for giving us his time, because we know that he has got a very busy schedule. And along with that, I also thank all the speakers who are coming from different parts of the world and sharing their important viewpoints and the researches that they are doing on this area of linguistic machine learning and fuzzy. This interdisciplinary area, it is indeed. And we really heartily thank on behalf of the School of Applied Science and Humanities and Haldia Institute of Technology once again for being with us here today. And today, with everybody's permission, we are closing the session, and tomorrow is going to be our last day. Hope you all would be with us again. So till then, please give us the permission.
Okay, thank you.
Thank you, sir.
Thank you,
Thanks.
Dr. Jana.
So,
Thank you.
sir, last but not least, so already I can declare the Professor Som has arranged another big international conference at IIT BHU. Those who are interested to join this optimization and
Just
nonlinear mathematics,
after
so
5
you can, sir, please announce your theme of the conference,
Yeah.
which will be held on the 21st December to 23rd December at IIT BHU. Please announce.
This is a conference on nonlinear applied analysis and optimization with soft computing. Okay, so we have a session on soft computing one day. And since that 22nd is National Mathematics Day, we have the session on number theory and algebra. And other 2 days we have optimization and nonlinear analysis. Dr. Jana is already having the brochure and other things. And like that. So,
And I
Okay.
think Professor Jana will be sharing that brochure with all of
yeah,
us. And as you
yeah,
were saying, probably he is also going to deliver a talk
yeah. He has
there.
already shared, I think, I hope that he has already.
Yeah, he was sharing with all
Some
of
of
us. So
your students have
congratulations.
joined, will be joining.
Okay, so Professor Jana, please share with all of us here. Some of the international speakers are also here. So later on, if you kindly share it in our Telegram group of this webinar, then I think all will be benefited. And if you kindly email all of them
We
to all
will
of
have
them.
actually even YouTube
Okay,
streaming,
okay.
and therefore,
Yeah,
with
people can
Professor
also
Jana,
join
public
there.
can have a look.
Okay. Thank you so much, sir. And this is how one conference or one webinar leads to the next one, and this is how knowledge spreads. So thanks to all once again, and good night to all. Tomorrow we'll be meeting again at 2 p.m. Till then,
Thank
bye.
you. Thank you.
Okay, thank you.
Thank you.
Thank you. Good night.
Thank you.